What if an observatory caught a signal from empty sky? Then, 3 years later, a dark world appeared there. No star blinked wrong, no comet tail warned anyone, just one brief pulse, then blackness, then an object. Tonight, we test the strangest explanation. What if a hidden planet lives almost next door? And what if we noticed it backwards? A telescope in a desert sees mostly patience. Cold domes open, mirrors tilt, computers wait for noise. Usually, the sky changes slowly, almost politely. This time, it did not. A sharp radio burst flashed from one exact direction. The signal lasted only milliseconds. Then every optical image showed almost nothing there. That contradiction is the whole mystery. How can something shout without showing itself? Start with the first minutes after detection. Astronomers would check for broken equipment first. Loose cables can imitate the universe. Satellite interference can fake distant events. Reflections can fool instruments near the horizon. But this direction stayed clean across later checks. The coordinates pointed above the Atacama night. Dry air, dark sky, excellent seeing. A perfect place to trust your instruments. That made the emptiness feel worse. The first consequence is simple. If the pulse was real, something energetic happened. Not nearby on Earth, not inside the detector. Something out there released a burst of power. Yet the sky patch looked blank. No obvious star, no exploding galaxy, no bright flare. Just a quiet region, almost boring by appearance. That pushes us toward hidden objects. Things that exist but barely reflect light. A hidden planet sounds ridiculous at first. Planets do not usually fire radio bursts. Stars do. Pulsars do. Magnetars definitely do. So why even consider a planet? Because the signal may not come from the planet itself. It could come from its environment. A magnetic field, charged particles, trapped plasma, impact debris. Jupiter already whispers in radio waves. Its magnetosphere crackles constantly. Scale that up, and stranger things become possible. Now move from the pulse to the missing object. Why would a planet stay invisible for years? Because darkness in space is easy. A cold world far from any star reflects little. A black surface reflects even less. And if it drifts against crowded background stars, it can hide inside ordinary sky noise. Think about what telescopes actually see. Not objects. Light. Remove enough reflected light, and mass becomes anonymous. A rogue planet, or nearly rogue planet, could do that, especially if no one expected motion there. Most sky surveys hunt bright changes first. A dim, slow shadow can slip through. The signal would arrive before the image made sense. Then comes the second consequence. Astronomers revisit old frames. They stack exposures, clean artifacts, compare seasons. Still nothing obvious on the pulse night. But repeat images years later show a dark body. Not glowing, not streaking, just present. That matters more than brightness. Presence means position changed enough to separate from background confusion. The object may have always been there. It simply stopped hiding well. So what changed between the pulse and later images? Several things could. First, geometry. If the object shifted relative to distant stars, its outline could emerge from a crowded field. Second, illumination. A faint star, brown dwarf, or dust glow might catch one side at a better angle. Third, temperature. A recent event could warm dust around it briefly. Not enough to make a beacon, enough to reveal a silhouette. But the most interesting answer is motion. A hidden planet may not orbit a bright star nearby. It could wander in the outer dark, slowly, quietly, almost detached from any sun. Then why the radio pulse? Because space is not empty around moving planets. Plasma streams through it. If a dense cloud, shock front, or moon-sized fragment hit that magnetosphere, the system could flash. Not with visible light first, with radio energy. Jupiter gives us a hint. Its auroras and radio emissions link to charged particles. Its moon Io helps drive some of that drama. Now imagine a larger magnetic engine. Imagine a colder planet with stronger field lines. Imagine debris falling in after ages of calm. For milliseconds, the sky would stop being silent. Then the source cools, spreads, and disappears. An optical telescope arrives too late. The scene already went dark again. That creates a weird timeline. The signal is the first clue. The image is the delayed clue. The object itself might predate both. We notice the event before the actor, then seeing the storm hours later. Only here, the delay is years, and the mountain may be a planet-sized shadow. Now ask the dangerous version. What if this world is not distant at all? What if it sits inside our broader neighborhood? Not Earth close, but close in cosmic terms. Close enough to tug icy bodies, close enough to reshape old maps of the outer system. That idea has appeared before in science, not a confirmed hidden planet nearby, but the logic exists. Astronomers infer unseen things from their effects. Neptune was predicted from orbital disturbances. Dark matter is inferred from gravity, not direct sight. Even exoplanets often appear through wobbles and dips. Space reveals itself indirectly all the time. So a hidden planet is not absurd. The absurd part is how we might find it. If such a world lurked far beyond Neptune, its reflected light would be miserable. It could sit billions of kilometers away. Sunlight there weakens dramatically. A dark surface would absorb most of what remains. Visible telescopes would struggle. Infrared surveys might miss a very cold body, especially if background subtraction removed it as noise. The planet would not need magic, just distance, darkness, and bad timing. Now play out the first hours after confirmation. Teams would check old survey archives immediately. Every image from that sky patch matters. They would search for slight movement across years, not cinematic movement, barely measurable drift. One pixel today, another later. That tiny displacement could reveal distance. Closer objects move against background stars differently. Farther objects creep more slowly. Parallax becomes the judge. Then comes the first day. Orbit models explode across whiteboards. Is the object bound to the sun? Is it passing through from interstellar space? Is it paired with a faint brown dwarf? Could the pulse mark an interaction with a moon? Every answer creates a different solar system. Every wrong answer wastes months. And one possibility would change everything. A massive, hidden world would influence comets. That matters because outer planets are not isolated. They are traffic controllers for ice and rock. Jupiter redirects bodies constantly. Neptune shapes the Kuiper belt. A new planet would rewrite the routes. Long-period comets might need reclassification. Odd orbital clusters could gain a fresh cause. Even some old anomalies would get new attention. Not proof, but a pattern. And patterns are where hidden planets stop sounding fictional. The next days get stranger. Observers around the world shift priorities. Night after night, the object is tracked. Spectra are attempted, though faint. Thermal signatures are hunted. Nearby dust is measured. Any sign of rings, companions, or outgassing matters. One dark sphere can become a whole system. And if a moon caused the radio event, the real discovery is suddenly two bodies, not one. Now imagine the object has an atmosphere, something heavier, colder, dimmer. Methane haze, nitrogen ice, hydrocarbon smog. In visible light, it could look almost cut from space, a matte shadow against stars. But in infrared, it might whisper heat. Not much, just enough to show internal energy still leaking out. That would make the mystery deeper, not simpler, because warmth means activity. Activity changes the story. A geologically dead rock stays quiet. A warm giant can generate fields and storms. If the world rotates quickly, its magnetic field may be intense. If it hosts moons, their interactions can drive radio bursts. If charged particles from the sun reach it, they can trigger auroral emissions. Suddenly, the original pulse looks less alien. It looks planetary. Rare, but planetary. Then comes the unexpected twist. The dark object might not have appeared later. It might have become visible because of where we stood. Earth moves. The planet moves. Background stars stay far. 3 years can completely change contrast. A hidden body crossing a denser star field can vanish into visual clutter. Cross into a cleaner patch and it pops out. Not brighter, just less disguised. The universe hides things with backgrounds alone. There is another twist, too. The pulse could be unrelated, same direction, different distance. Space stacks objects along one line, a remote radio burst and a nearby dark planet. That would be the cruelest answer, a coincidence strong enough to invent a myth. Astronomers fear that possibility for good reason. The sky loves false partnerships. One line of sight can hold many stories. So how would we test the connection? First, repeat signals. If the object emits again, suspicion rises fast. Second, polarization and frequency patterns. Planetary radio processes leave signatures. Third, motion matching. If later bursts track the object's drift, the case becomes much stronger. Fourth, surrounding environment. Dust, plasma, or a moon would support interaction models. Without these, the planet remains only adjacent. Interesting, but not guilty. Now zoom out. What would a confirmed hidden planet nearby mean? Not panic, not impact headlines. It would mean our map is unfinished. The solar system would gain a new chapter. Textbooks would stretch. Formation models would be reworked. How did such a world stay dark? Was it born here and scattered outward? Was it captured from another star long ago? Did we overlook it because our searches favored brightness? Each answer changes the past. A captured world is especially wild. Stars form in crowded nurseries. Young systems can swap or steal bodies. A planet ejected from one system might be trapped by another under rare conditions. If that happened here, our outer neighborhood contains an immigrant. A world with a different origin story, different chemistry, different moons, different scars. Not just another planet, a survivor from stellar chaos. But an ejected native world is just as dramatic. Early giant planets may have migrated violently. Smaller worlds could be flung outward. One survivor might settle into a distant, elongated orbit. Too far, too dark, too slow for easy discovery. It would still belong to the sun, yet feel detached from everything familiar. A frozen exile carrying evidence of the young solar system. Hidden not by impossibility, but by time, distance, and neglect. There is also a practical consequence. Search strategies would change overnight. Astronomy often hunts bright transients and obvious motion. A dark, nearby world demands the opposite. Long patience, deep infrared, repeated parallax measurements. Better subtraction methods that preserve faint movers. Wider surveys of star-poor regions. Even radio observatories would gain a new role. They might catch the disturbance before telescopes catch the body. The warning could arrive before the picture. That reverses a common assumption. We imagine seeing first, then understanding later. But sometimes physics speaks before shapes appear. A magnetic cry, a gravitational wobble, a thermal excess. The universe leaves fingerprints in the dark. If a hidden planet exists nearby, its first introduction may not be visual at all. It may be a side effect, a tug, a whisper, a burst. Evidence arrives crooked. And that is why the Atacama-style scenario matters. Not because one burst proves a secret planet. It does not. It matters because the sequence is believable. Signal first, image later, explanation last. That is often how discovery actually feels. messy, delayed, indirect. The sky does not reveal itself in order. We impose order afterward, sometimes years afterward. By now, the strangest part is clear. The empty sky was never necessarily empty. It may have held a world all along, a cold, dark body crossing unnoticed until one brief interaction betrayed its presence. Then the planet slipped back into near invisibility, waiting for geometry, patience, and better images. Not a monster, not a fantasy, just a missed neighbor in terrible lighting, which is almost more unsettling. Because if one such world can hide, what else hides in the dim outer edges? Not countless giant planets packed nearby. Physics does not allow anything we want. But a few overlooked bodies? A moon system